The carbon atom has 6 electrons. These electrons have the following orbital configuration: 1s2, 2s2, 2p2. This means that there are 2 electrons in the inner 1s subshell, 2 electrons in the 2s subshell, and 2 electrons in the 2p subshell. The 2 electrons in the 1s subshell are not of interest in organic chemistry, so we'll leave them for now. We are now looking at carbon's valence electrons, which are those that are used for forming bonds. Let's check out how they are arranged. 2 electrons are orbiting in the 2s orbital, and 1 electron is orbiting in each of the 2px and 2py orbitals. As you can see, the 2pz orbital is currently empty. Carbon normally forms 4 bonds, but here, only the 2 2p electrons are unpaired and available for a chemical bond. How can that be? We can get 4 unpaired electrons through an excitation of one of the 2s electrons into the unoccupied 2pz orbital. Carbon is now almost ready for forming bonds. Carbon bonds depend on the type of hybridization that takes place in the electron orbitals. Hybridization is a process where the orbitals mix to form hybrid orbitals. Let's see the different types of hybridization, starting with the most simple, the sp3 hybridization. In order to form 4 bonds with other atoms, the 2s, 2px, 2py, and 2pz mix to form 4 equal orbitals, called sp3. This is the process of hybridization. The sp3 orbitals form the 4 corners of a pyramid with triangular sides, a so-called regular tetrahedron. The angle formed between the orbitals is 109.5 degrees. With the sp3 orbitals, each occupied with a single electron, carbon can form 4 equivalent single bonds with, for example, hydrogen. These are called sigma bonds. The angle between the orbitals will determine the angles between the chemical bonds the carbon atom will make. So when forming sp3 orbitals, the angle of the bonds will be 109.5 degrees. A carbon atom can also bind to another carbon atom using a sigma bond. The rest of the sp3 orbitals can then form more sigma bonds with other compounds. For instance, with hydrogen to form ethane, as shown here. Let's have a look at another type of carbon hybridization, sp2. With sp2 hybridization, the 2s, 2px and 2py mix to form 3 equal orbitals. The pz orbital will stay intact. The angle between the sp2 orbitals is 120 degrees. The sp2 hybridization is used when carbon forms double bonds, for example with another carbon. One sp2 orbital is used for a sigma bond. The pz orbital is used to form what's called a pi bond. Even though the pi bond locks in 2 places, it only corresponds to a single bond. The remaining sp2 orbitals can bind with sigma bonds to other atoms, such as carbon, oxygen, or hydrogen. The bond angle will, as before, be determined on the angle between the orbitals, and will therefore be 120 degrees. If carbon only bonds with hydrogen atoms, an ethene molecule is formed. Let's have a look at the sp hybridization, the last one for now. In sp hybridization, only the 2s and 2px mix to form 2 equal orbitals. 2py and 2pz stay intact. The angle between the sp orbitals is 180 degrees. The sp hybridization is used when carbon forms triple bonds, for example with another carbon. As with sp2, a sigma bond is formed using one of the sp orbitals. Two pi bonds are formed with py and pz. The remaining sp orbitals can form sigma bonds to other atoms. The angle between the two sigma bonds will be 180 degrees. If only hydrogen atoms are bound to these remaining orbitals, an ethyne molecule is formed. That's it for now. Let's go back to the lab for a little quiz to see if you've got this.